Hello everyone. In this video what we are going to look on is to convert rectangular coordinates to polar coordinates, right? So, question number 1, change each of the following rectangular coordinates to polar coordinates. Part A, 0, 2. Now, before you are able to convert a rectangular coordinate to polar coordinate, you must remember that rectangular coordinates are plotted in the form x, y, while polar coordinates are plotted in the form r, theta, and theta is measured from the x-axis, from the positive x-axis, in an anti-clockwise direction. Theta is also normally written in radian, right? Now, there's two formulas you need to remember. You need to remember that r is equal to the square root of x squared plus y squared, right? And theta is equal to tan inverse of y over x, right? So, let's convert the first point here. So we know we want to convert 0, 2. We know what this means. This is saying that x is equal to 0, and when x is equal to 0, y is equal to 2, right? Now we're going to plot this on an xy plane. So here is our y, here is our x, right? We know that here this is 0 degrees, this is 90 degrees, 180 degrees, 270 degrees, and right back here is just 360 degrees, right? Now, if we're going to plot this point, we need 0, so 0 would be here on the x, and we need 2, so y is 2, so we go up to 1, 2. So let's say that this is where the point is, right here at 2, right? Now, if this is where the point is, and we want to convert this point, what is r? R is just the distance from the origin to the point, which is just 2, right? So clearly here we can see that r is equal to 2. What theta is going to equal to? Theta is going to equal to 90 degrees, because if you measure from the x-axis in an anti-clockwise direction, it brings it to this line here, which is 90 degrees. So theta here is 90 degrees. But we want theta in radian, so all you need to do is to multiply 90 degrees times pi over 180, and that is going to give you pi over 2, right? So, therefore 0, 2 in polar is r, which is 2, the angle, which is theta, which is pi over 2. Alright, so that's the coordinate of this point in polar form. Clear there? That one was an easy one, right? So now, let's look at the part B. Now, for part B, we have the coordinate 3, 3. And what this is saying that x is equal to 3, and when x is equal to 3, y is equal to 3, right? So we need to determine two values, which is r and theta, right? But before we can do that, we're going to plot this. So if we're going to plot this, we know that x is equal to 3. So here we need 1, 2, 3. And y is equal to 3, so here we need 1, 2, 3. That's about it. So we go across 3, and then we go 3 up, which is about here. So the point will locate here. So we need a line, which is the radius that connects this point to the origin. So we're going to draw a straight line to this point here. And this line would be the radius, which is r, which is what we want to find. So we want to know what r is. Now, how do we know where theta is? Theta is measured from the x-axis. So we know that this is x and this is y, right? And this is negative x and this is negative y, right? So if we're measuring from this line in an anti-clockwise direction, then this is the angle that we need. So theta is going to be here. Now, how can we determine theta? We can complete this right angle triangle here, because what the rectangular coordinate is saying that you make 3 movements horizontally, and this is 1, 2, 3. So all of this is just 3. And then you make 3 movements vertically or along the y, and this is 1, 2, 3, which is this. So all of this side here is just 3 as well. Now, with all of this information, we can easily determine what r is, and we can easily determine what theta is. Now, if we use this formula, we know that r is equal to the square root of x squared plus y squared, right? So r is equal to the square root. What is x? X is equal to 3, right? So we just need to square that. So this is going to be 3 squared plus y, which is 3 squared. So r is equal to the square root. 3 squared, that's just 9, so this is going to be 9 plus 9. So r is equal to 9 plus 9, that's just the root of 18, right? Now, we want our answer insert, so what I'm going to do is to rewrite 18 as a product of 2 numbers. But I want one of the numbers to be a perfect square. So I'm going to say that r is equal to the root of 9 times the root of 2. So 9 here is a perfect square number, right? So what's the root of 9? Root of 9 is just 3. So final answer is just 3 root 2. Right? So our R value is 3 root 2. Now we need to determine what theta is. And we're finished basically. So we know that theta is equal to tan inverse of y over x. But what is y? Y is just 3, right? So that's just 3 over 3. So theta here is equal to tan inverse of 1, right? Because 3 over 3 is 1. So theta is equal to tan inverse of 1, that's just 45 degrees, right? Clear there? So tan inverse of 1, that's just 45 degrees. But what's 45 degrees in radian? Theta is just equal to pi over 4. Because that's just half of 90, right? And we know that 90 is pi over 2. So half of pi over 2, that's just pi over 4, right? Now, so therefore, our final answer, therefore, 3 Therefore, 3, 3 in polar is just 3 root 2, 5 over 4. And that's how you would convert a rectangular coordinate to polar coordinates. Alright? So let's look at the other one. So part C, we have minus 3, 2. So here, we know that x is equal to minus 3. When x is equal to minus 3, y is equal to 2. Again, going to graph it. Now, x is equal to minus 3, that's over here, right? So that's negative 1, negative 2, negative 3. So negative 3 would be about there. And we must go positive 2, so we're going to have positive 1, positive 2. That's where positive 2 would be. So the coordinate would be, you go up from here, right up to 2, and that's about it here. So the point would be here. Now we need the radius, so we need a line connecting this point to the origin. And this line is the radius. We don't know what this line is yet. Now we can simply complete our triangle here. Right? Which angle do we need? We need theta. But where is theta? Is theta inside the triangle or outside of the triangle? Now remember, you measure from the x-axis in an anti-clockwise direction. So let's see. If we're going to measure from here in an anti-clockwise direction, then this is the angle that we need. So theta is this angle. Right? But here we have a triangle. Means that, let's call this angle something else. So this angle here is beta. It means that if we determine the value of beta, then we can easily determine the value of theta. Since we know that here is just 0, here is just 90 degrees, and here is just 180 degrees. So we know that we can easily determine what theta is if we know what beta is. Now, can we determine what r is? Yes. So we know that r is going to equal to the square root of x squared. But what is x here? X is minus 3, so that's going to be minus 3 all squared plus 2 all squared. So r is equal to 9 plus 4, because negative 3 squared, that's just 9. 2 squared, that's just 4. So r here is equal to the root of 13. Right? Now, what we can do is to determine what beta is. Since theta is equal to tan inverse of y over x, beta is equal to the same thing, don't it? So we can say that beta is equal to tan inverse of y over x. So beta is equal to tan inverse of y. What is y here? Y is just the y value, right? Which is 2. What is x? We want the length of this triangle up to this point. So what we're going to do, we're going to use the absolute value of negative 3. So we're going to use 3. So that's just 2 over 3, right? Because we don't measure length in negative numbers. It's always positive, alright? So that's why I use the absolute value of negative 3. Now, if you take the tan inverse of 2 over 3, then beta is basically equal to 33.7 degrees. Right? But remember, beta is not what we want. We want the angle theta, which is this angle. But beta is only helping us to determine the angle of theta. So we can therefore say that theta is therefore equal to this angle here, which is 180 degrees, minus beta, which we just calculated, which is 33.7, right, degrees. Now, theta is equal to 146.3 degrees, right? Because 180 minus 33.7, that's just 146.3 degrees. But remember, we want theta in radian. So here, theta is just equal to 146.3, and to convert this, just multiply by pi over 180, so this is just 146.3 pi all over 180. So that's the angle in. So therefore, this point here, which is negative 3, 2, 2 polar, is just r. What is r? Root 3, right? So that's just root 13. Sorry, not root 3, root 13. Comma, the angle which is theta, and that's just 146.3 pi all over 180. And that's how you would convert this coordinate to polar. Alright? So let's look at part D. Now for part D, we have the coordinate -4, comma, -4. Again, x is also equal to -4. While x is equal to -4, y is equal to -4. And you know what I want to determine, right? I want to determine the value of r. I want to determine theta. So what are we going to do? We're going to sketch it. So we're going to sketch this first. These coordinates are going to be found in the third quadrant. So this is the first quadrant. Quadrant 1. This is quadrant 2. And this is quadrant 3. So we know that minus x is right over here. That's minus x. And minus y is here. So that means that this coordinate must fall in this quadrant. So that means we're going to go 4 across, which is to the x. So we're going to go -1, -2, -3, -4. And we need 4 down to it, which is -1, -2, -3, -4. So we know that -4 is here on the y, and we know that -4 is here on the x. So that coordinate is going to be along the x down, so it's going to be somewhere around here. Let me see, go down straight, like that, then we come across. So the point would be just about here. Right? That's where the point would be. Now we need the radius, and that's the line that connects this point to the origin. So it would be a line like this. Right? So this would be r. Now, we know that this distance here, which is the height, that's just -4. Right? And this is just -4. Right? So we can determine this angle here, which is inside of the triangle. Let's call it beta again. But which angle are we interested in? We're interested in the angle that you measure from the x-axis in an anti-clockwise direction, or sometimes called counterclockwise direction, which is all the way around up to this line. That's the angle that I want. Now, we know up to this line, this angle is 180 degrees, up to this line here. We know that here, this is 90 degrees. Know that this is 0 degrees. Know that this is 270 degrees. So we know that the angle that we want falls between 180 degrees and 270. So the angle is greater than 180. Follow me there? But it is also less than 270. Right? Now, go ahead to calculate r. So r is equal to the square root of -4 squared plus -4 squared. So r is equal to the square root. 4 squared, that's a 16, plus 4 squared, that's a 16 again. So r is equal to 16 plus 16, that's the square root of 32. I'm going to rewrite 32 as a product of a perfect square number times another number. So r here is equal to the root of 16 times the root of 2, right? Because 2 times 16 is 32, right? So r is equal to, what's the root of 16? That's 4, so this is 4 root 2. So that's our r value there. So r is equal to 4 root 2. So we just need to determine the angle. But this is the angle that we want to determine, and we see that all of this angle here, this blue, that's just theta. Right? So we're going to determine beta. Right? Before we determine theta. So beta is going to equal to tan inverse of y over x. Of y over x. Right? So beta is equal to tan inverse of just 4 over 4. And 4 over 4 is just 1, right? So beta is equal to tan inverse of 1. And tan inverse of 1, beta, is equal to 45 degrees. Right? If you take tan inverse of 1, that's us 45. But we know we want it in radians. So 45, beta here, is the same thing as us pi over 4. Right? Now, we know that here is 0. Where 90 is, this is the same thing as saying pi over 2. Where 180 is, that's the same thing as just saying pi. So this is the same thing as saying pi. Or, it's the same thing as saying 2 pi over 2. Right? So this is the same thing as saying pi or just 2 pi over 2. Because since we're adding up by pi over 2. So here, if you have 1 pi over 2 plus 1 more pi over 2, that's what's 2 pi over 2. But 2 pi over 2 cancel onto the just being pi, right? But I'm going to work with the 2 pi over 2. So I know that this angle here, which is beta, is pi over 4. So what is theta then? Then theta is going to equal to this angle all the way to the line, which is 2 pi over 2. It's going to be 2 pi over 2 plus beta. We add this piece to it, which is just pi over 4. Clear there? So, theta is equal to, multiply this by 2 over 2, because we want the denominator to be 4. So this is going to be 4 pi over 4 plus pi over 4. So theta is equal to 4 pi over 4. Keep the denominator 4 and add that at the numerator. So this is 4 pi plus 1 pi. That's just 5 pi over 4. So the angle is 5 pi over 4. So this coordinate here is just 4 root of 2 comma 5 pi over 4. Right? So when we convert negative 4 comma negative 4, that gives us 4 root 2 comma 5 pi over 4 in polar. Alright? Thank you for watching. Please remember to like, comment and subscribe.